All right, so welcome to the Run Scala Faster using the GraalVM platform session. My name is Amitpal. I'm part of the Oracle Labs team, and very excited to be here. I'm going to keep it interactive. If at any point you have any questions, feel free to stop me and ask a question. And if you will, I'll also be available for a short time right after this session as well. So. It's just since we are part of the lab's research, sometimes we have forward-looking statements, so some caution on that. And so now to the interesting stuff, right? So GraalVM is basically a high-performance polyglot virtual machine, right? It's a modern JVM. So the idea here is that we can support a wide variety of languages in terms of being able to have those interpreters and compilers across a shared runtime so that you can run a lot of these, basically different implementations of your languages and so forth, as you'll see. So we support JVM languages, and that includes, things like Java, Scala, and Kotlin. So we're going to be focusing today more on the Scala aspect of things, but at the same time also lightweight languages, right? So that includes things like Python and others like Ruby and so forth. So just a show of hands, how many people have heard of GraalVM, before this week and so forth? Okay, because there's been a session, so So okay, and how many people actually have used that GraalVM? At least the community edition. Okay, that's it's pretty cool. So that's great, and so obviously we have implementations of Ruby. We call Truffle Ruby, and R, what we call Fast R, and accordingly with JavaScript and so forth. Even with Node.js, we actually support the latest ECMA script, basically in terms of the. I believe the draft is in the final stages, so we actually have support for all the different variations of the libraries and languages. And also LLVM languages. So we support C, C++ code via LLVM, backend, right? So and that's pretty interesting because we start to see requirements for where there's sometimes a lot of legacy code. People start asking us questions on even COBOL these days. You would imagine. We are way more advanced. I mean, it's a hybrid requirement. So GraalVM gives you that basically that single runtime, if you will. So breaking down a little bit on the architecture, you will see that this high performance, it's a multi-layered architecture. It's built on the Java Hotspot VM. So it plugs into the Java Hotspot via the JVM CI, which is the compiler interface. So in that sense, so we support both the just-in-time and also the ahead-of-time capabilities, right? And so the Graal compiler is modern, modular, and so forth. It's written in Java, right? So if you know of the traditional C1, C2 type architecture, so you can think of this as the C3. So it's like a meta language runtime. Think about language virtualization in that sense. And then we also have the Truffle framework. So using the Truffle framework, you can basically use the interpreters that we've already got, including JavaScript and R that I mentioned earlier. But you could also likewise bring your own languages. So if you have a syntax that is similar to Java, JavaScript that you want to be able to create, we have those the AST framework, so all the syntax trees and so forth, and you can actually write your own languages. In fact, we have some references of customers doing that on our site. You'll be able to actually see that and so forth. So I'll talk about one or two of the customers who've been doing something interesting there. So that's pretty much, from the architecture standpoint. That's kind of like the most important one when we look at GraalVM on the top, where we have the translation of the interpreters and compilers and so forth. You can also embed this as part of embeddings in any particular architecture. Obviously in Hotspot, from JDK 8 onwards, and in JDK 11 also going forward. Node.js, as I mentioned. And also in various databases, right? So you could actually run a lot of these, say for example, if you want to be able to run a JavaScript in the database, prevent network latency and things like that, you can actually do that across the stack. And the most important thing here that we're going to be talking about is the native code, right? So like for example, in Scala, you want to generate native code that is independent of it's a standalone executable, right? Script in that sense. You can use it for like IoT devices and things like that. So we'll talk quite a bit on that with the demo and so forth. So that's one of the most important ones, basically that one architecture. So that environment kind of helps you fit the different types. And the key thing here is high performance is one, but also the other part is the polyglot nature. So I'll try to draw some similarities to Scala and the polyglot function. As you already saw, maybe on our website, we've already got polyglot capabilities across other areas. For example, in a shared, a single runtime, you want to be able to run Node.js, Java, and also R, for example, for plotting and so forth. You can already see that, right? So that's the idea of the universal, virtual machine, right? Essentially. So the Graal compiler is basically written in Java, right? So that's a very important piece, because in the past, a lot of it was kind of tightly coupled together with the hotspot and so forth. So now that's it's been made more modular. So that you can actually tap into it, you can access it, and so forth. It's not so tightly coupled in the hotspot layer. So that gives you that pluggability, so that you're able to extend it and write your own extensions or instrumentations and so forth with it. You've already seen some of what the customers are doing. It comes in two flavors. So basically, one is the community edition, and the other is the enterprise edition. So the community edition is basically comprised of what you download out there. You already can get your 5 to 7% performance overhead and capabilities like that. The enterprise edition will obviously come with more performance on top of it, 20, 30% and things like that. And also, we're having a good discussion on things like isolates, security, sandbox capabilities and so forth like that. So that's another one that comes in this day. I saw like some posts out there, people were talking about security vulnerabilities and so forth. So if you want to start looking at things like how to prevent things like buffer overflow attacks and so forth, timeout conditions, then maybe you want to be able to explore the second option. Under the hood, why and how is GraalVM unique in the sense that how do we deliver this high performance? How do we deliver the security capabilities? We have these advanced optimizations, and these include things like partial escape analysis. In the older versions of the compiler, there were things like escape analysis. So now you have things like partial escape analysis. You have things like path duplication, and also priority inlining and so forth. So it's not just it's like it's happening like one at a time, but you're actually having all these optimizations working in tandem together as well, right? So that's a key part of how it's actually done. So here's an example. So you see the concept of streams and so forth is kind of common, and also when you look at Scala, you have these collections and so forth, right? It's kind of high-level abstractions and so forth in Scala, typically that we see in terms of these that are done. So now, once you use these combinations of optimizations and so forth, you're able to then come down to a level where it gives you what you need as that next step, what we call iterations and so forth, right? So that's a very important piece, especially when it comes to Scala and things like that as well. So. And what's the motivation behind that, right? So say, for example, once we have developed these optimizations, we have brought them out there, you start seeing the changes within the code syntax. What we have also done is we've gone out there and actually built a benchmark. It's a vendor-neutral benchmark, so it's actually presented at one of the prestigious programming language conferences and so forth. And it actually showed how some of these optimizations, things like inline profiling, vectorization, and so forth, was able to show with a y-axis of speed up, versus JDK8 basically, and on the right-hand side, really the focus on the geomean on the right, you start seeing on the red flag, you get 32% performance, right? Versus with the community edition, which is 6 to 7% in that sense, right? So. And we have it's gone across different types of specific benchmarks. So we've also done it specific to Scala, and it actually shows the best results for Scala. So in the words of some of the folks who have been using it, and for example Twitter, they said that on Twitter, if you use Scala and you're not using Graal, you should be using it basically. If you're using that, it's a win-win opportunity essentially for you from the inside out. So you can start seeing it across all the different types of tests, and this is how and why basically Twitter has been using it right across the stack and so forth. So it's an important part, that we're getting that almost 38% improvement and things like that. So every time in Twitter, when they are tweeting the tweets and they're dispatching the code, dispatching those tweets and so forth, it's actually using the Graal compiler in that sense, right? So that's an important part from that native capability and so forth. So here's just a reference point. I think there was a very good talk on using Graal together with Scala, and what are some of the benefits using microservices and things like that, and how it actually reduced a lot of the overall object allocations, and also the accelerate the execution speeds and things like that, right? So whenever the tweets are going out there and so forth that you see today, right? So that's a very, very interesting part. So this is libgraal. So it's something that we released over the last year, because one of the things was the warm startup sequence, as you can see on the left, and then with the Graal jar and so forth. So in the initial part, it used to take time, and now it's obviously shortened. But over time, the iterations were obviously smaller anyways. So the key thing here is that we have actually added that. So now it's part of the JIT compiler in the hotspot. And so that's another thing that we have released over the last year and so forth. So I encourage you to use the latest, versions, so version 19 for that and so forth, right? So you don't get any interference and so forth, your GC and profiling and things like that. So we'll release even more of these resources down the stream and things like that as well. So it's packaged as a native image. And on top of it, it isolates easier for each compilation. So then it just throws away what you don't need from there. And the first run becomes on par with your C2, right? So in that sense. So here is basically Graal for your compilation. So we actually did it across all the different types of important ones that you see in things like akka, Lichness, and Guardian, and so forth. So we did Bloop, which, as you know, is a Scala compilation, in that sense. So we also did that same test using others, for example. And we are able to get consistent results, right? So we start seeing that with JDK8, Java, and then GraalVM with the guided optimization, giving you pretty good results. Obviously, the lower is better here, right? So when you look at the normalized time on the left-hand side, so that's an important piece that you get from that instant startup and low memory footprint. It's almost like 25-30% speed up capabilities there. So that's basically done with the Bloop, Scala compilation framework and so forth. And also similarly, it was also the same numbers were achieved using Hydra, and so there was consistency between the two in terms of the Scala compilation frameworks and so forth, right? So what we see here is that basically in these types of benchmarks and so forth, a lot of the the pipelines, it basically just paralyzes a lot of the build times and things like that. So that's a very, very huge win in terms of being able to use these kind of compilation and comparisons and so forth, right? So I mean, we all know that even before we see this, that Scala compilation tends to be slow, right? So giving you these kind of speeds and so forth, it really enhances the productivity that you really need, right? So and so it's an absolute very good thing that's happening. Yeah. Next is basically Graal with hotspot. So a lot of conclusions here. So in terms of setting it up and how you run it, while we are talking now, it's basically just pointing to the class path. You can actually download it and run it, point at the class path, and you're able to start running your code accordingly there. You'll see it very shortly. So JDK8, you can download the CE, point to the path of Java home like what you used to. It takes like a few seconds. It also there's we have like a Maven plugin where you can integrate it as part of your CI/CD sort of tools if you want, and that makes it automated if you will, and also with IDEs and things like that as well. So in production you're getting like 35%, and that's a productivity boost, right? So because as you saw, like nowadays in the cloud provider space, if it's not running there, you're going to have to do a lot of warm up things. So if you get that instant startup capabilities, that'll be a big thing. So the key thing is imagine, like, say for example you have thousands of machines, right? And for each time you're getting this 35% multiplied by those thousands of machines, right? And say you have like 10, 20, 30 for example employees, and on top of it some of the machines that you're doing could be just for CI/CD. You just add the numbers up, you'll be getting huge performance gains, productivity boosts there for project compilation, and some people working in different environments and things like that as well. So the native image is so as we are basically looking at the input for the native image generation, we're looking at different artifacts, classes, and so forth. Substrate VM it's packaged together with the Graal suite, GraalVM suite. So it's basically native compiled with Java, written in Java. So what it does is goes through the points analysis. So it's like an iterative sort of function, and then you can actually do things like pre-initialization and so forth as well, right? So this way. You can parse ahead of time. You can do serialization of the heap and then generate the AOT snapshot, basically the native executable and so forth, right? So the output is your native executable, right? So that's an important part. So here is a very simple. What we have done is we've created a native executable. So we'll just quickly shift here, showing you the actual difference. So ahead of time. We basically initialized using SBT and so forth. We've created the Scala image, and you can actually go and download this. This was actually done a couple of months ago in terms of a demo that we created. So it takes a while. You create that, and once you run that, essentially from if you want to be able to run this in a regular time for assuming this is not native code and so forth, it might take up to a certain 4 milliseconds and things like that as well, right? 0.4 milliseconds. So on top of that, if I then ran the native part, you can see the huge difference, right? It's almost instantaneous. That's about like 30, 40 times a jump, almost 50% difference. Keep in mind, I'm using the older version. So if you now use the newer versions, you're going to see even more instantaneous capabilities around there and so forth as well. So that's a simple one that basically shows you how the instant startup and low memory footprint for native images gives you that flexibility that you really need, and that's a huge plus, a huge win, right? So Scala native versus native image, right? So there are a lot of intrinsics in there when we saw the images and classes that need to be reachable. So all the JVM libraries will become available with GraalVM essentially. So you don't need to rewrite parts of the JVM ecosystem. So that's another one that you can actually translate quite a few of these native intrinsics and so forth. You can also do it using a compiler plugin, and some of the interfaces and so forth. Here is a comparison. This is a slightly older one, but I think still it gives you an understanding of the speed up against what we call Scala native and also native image, which is our profile guided optimization and so forth, right? So you can see that speed up and that variation and comparison and things like that. The demo earlier you saw, basically what we did was we just took and pulled down some demos and we ran an SBT package, and from there we were able to create these with the flags that you have and so forth, and from that generate the native code, and then you're able to run that native code and so forth. So when you compare to things like hotspot versus native, you can actually go and see on some of these Medium articles that we've published how much faster it is and things like that in terms of speed up and so forth. This is just some other snapshots of when you want to be able to do things like, so how many people have been using Visual VM and so forth, but you can also start looking at it for things like Scala. and you're running your Play core server and so forth, and you can actually go in and start looking at your garbage, GC activity, and at the same time you can look at your threads, profiling, sampling, and stuff like that. On top of it, if you want to be able to get more visualizations on some of the visualization of your GC and so forth, again, that's available through GraalVM. So now when you download GraalVM, it comes bundled with Graal. So if you go to GraalVM and hit it on GitHub, it'll come bundled with Graal and all that as well. So you can do that for a multitude of languages. So not just only Scala, but you also can go in and do things like memory profiling, heap analysis of objects and threads and schedules and so forth. Across a wide variety of languages and so forth. And that kind of tracing, profiling of instrumentation behavior is very good. And so you start even seeing it in Japan, and a lot of people are using it and so forth. Second aspect of, this is just a bonus, I just kind of added these more, but we're going to go reach the cross-compilation, cross-platform support very soon. But here is another example of how to run Graal and call an R file from Scala. So a lot of data science requirements is from calling R from within Scala. So you can actually initialize Graal context. You can create a source. Tell the compiler what kind of function that you want as part of the context evaluation, and then also print the string accordingly. So you can actually do that in a specific setting like that. There's been a lot of these, a lot of activity of people experimenting and doing this on GitHub today. So you go out there, basically you're able to see just huge amount of activity, just to give you a flavor of what some of the things that are going on. This is essentially the most important site for GraalVM. So from here, you're able to go in and navigate what are some of the things that you want to see. I was telling you about GraalVM that actually comes with Graal now. So you can actually download that as a GraalVM capability. If you want to go and look specifically at things like Scala and what you can do with Scala and some of the things I've been doing, you can just follow along, essentially run the code from within the site. It's a .org website. And the benchmarks that I actually explained earlier, basically the Renaissance benchmark and so forth is actually available here as well. So we actually benchmark against the OpenJDK baselines, right? So the other specific areas, for example, your SBT plugin for native image generation is also available there. And how it compiles ahead of time from that snapshot that we talked about. And who is basically using it in terms of production. Here are some other examples of how people are doing it. You have people using Scala and R, other aspects of real-world applications of Scala in HTTP4S using Graal, and this was actually done quite recently as well. So just a lot of similar examples that we are seeing. Another example here where you're using the polyglot function of Scala and also R, and a simple example over there. So it's a lot of activity and that's going on, and I just thought that sharing with you, and the idea is that you guys start looking at being able to pull and also create if there's anything that you need in terms of creating issues and so forth. It's a very active project that's been going on. I didn't say it, actually this is almost like a 7-8 year research project and that has been done. So here's another one. Yes, there is no Scala-specific microservices framework here, but just to touch on this and so forth, when you compare Helidon, which is a Java microservices framework, it's an open source, and then also Micronaut and Quarkus, you can see that with native image, you get almost like 35 milliseconds in terms of that startup sequence and things like that. So that's a huge plus, right? So Quarkus is actually from Red Hat. And there's been a lot of activity around that, so it's tailored for GraalVM in that sense. And then Micronaut as well, so this has been published, and then Helidon that's something from Oracle, from the microservices capability. And then the memory footprint, again, you start seeing 31, 41 MB and so forth. Even the Docker size image and so forth is less by 50% and things like that on top of that. Similarly, so it's consistent across both for instance startup and low memory footprint. So the idea here is that the GraalVM native image is ready for wide adoption, right? It's being, there's been benchmarks, there've been some customers using it, and obviously, but there are some trade-offs, obviously, that from native image, some of the classes and things need to be reachable and so forth. So we can do things like guided optimization, learning effect before that. We've actually shared what on GitHub, basically what are some of the features where you get the trade-offs and what are some of the unsupported functions for now. So you can actually go and look at that. If you have questions, you can come to me. So you can try it out in a framework, report any issues that you have. And we're actively working with the community. In fact, you'll see anytime there's a question on GraalVM, native image generation, you might be doing something for like, not just IoT, or maybe something for specific to Blu-ray discs, ahead of time compilation of code that is running in there. Again, we have responses to that. So variety of use cases that we are working on. Here is the profile guided optimization capability, and how it actually generates the instrumented binary. So it actually two different parts there, right? So with the workloads that you have, then you actually get the optimized binary and things like that, right? So you can collect your profiles for your performance of your native images, right? So this is what we call PGO as part of native image. So Scala macros use dynamic class loading. Again, this is something not always known at image build time, but we can actually build a custom native executable for a project where all the macros are actually needed. So this is again part of that lab that if you want to be able to run it yourself, you can see that as well. So that's that's something that I thought I'd share as well. So native image, very important part. So again here, this is the Quarkus Hibernate benchmark. You can see the requests per second going on. But over time, what happens is there's a slight dip. Obviously, it's a high consistency for the native image Enterprise Edition with PGO. You'd see the dip on towards the right hand slide slightly, and that's because we're doing some GC enhancements and things like that. So you will see that we'll be able to go past that soon as well. So as part of Apache Bench, right? So that's the little dip that we talk about. The cool feature here is the isolates. We just had a interesting chat earlier that you can have multiple heaps, right? So with this feature of you can have like one per request, and just throw it away once you don't need it, and when you're done with it and so forth, right? So there's a good blog post on that using with the Netty server and so forth as well on top of that. So that's an important part, right? Yeah. So that's what happens to the GC, and then in that sense. So here is, user time obviously is faster when we look at that. I think this is in that sense. And from that, just going back in your mind and circulating and thinking that, how you're going to have an ecosystem like that. It's not just, actually it's more than just a virtual machine. You actually have a collection of a lot of tools in there. Actually, the whole archive, when you unzip it from GraalVM, you'll have everything in there in terms of things like Ruby gems and, your Scala functionalities, your tools and so forth. So all in one, right? So if you download it, unzip it, you'll actually see it. I actually had it. So the key thing here is that now, with the remaining part of the presentation, to share with you the capability to extend this cross-platform. So you can run it in things like iOS, Android, and also desktop. Right? So how can we do that from within using the Scala capabilities and so forth as well? So as you know that we support the LLVM backend, right? And that's something that's important because in the future, if there are any changes from an Apple iOS standpoint, it would be good to have LLVM interpreter support. So the key thing there is that you can actually port Scala to niche architectures, right? So IoT specific use cases, mobile specific use cases, and all that. So, but of course, the LLVM comes with a price, and we talked a little bit about the trade-offs and things like that as well, right? So in that sense. So what we have done with GraalVM and JavaFX is we worked with a company, Gluon, and they work in that mobile space. So they do things like mobile connectivity and so forth. The idea here was to extend it so that we can actually look at from the server side, you already saw that we've got the Scala native code and all that, but the front end, also looking at it, going towards the React area, so you have your Java static libraries and so forth. So making it extensions for the mobile specific environment, so iOS, Android, and your desktop and so forth. So here you can have your mobile functionality for abstractions that you build on GPS or your camera and so forth, and then connectivity accordingly and so forth. So this is a pretty interesting one. Because Apple does not allow dynamic code to be run on some of these iOS devices, right? So, however, at the same time, we also know that JavaFX contains Java code, right, and also native code. So that's something that it could be a plus point. So Java code is compiled by GraalVM native. So this is available for iOS and also Android environments. So this gives you that leverage, right? So you can start thinking about iPhone, iPad, and also the AMD simulator and so forth. So what we did here was the basic one. We looked at using the Maven and the Gradle plugins, and we deploy a sample chat app on a desktop using created Scala and so forth. And then, of course, some OS-specific library tools. So the bottom part is something that's for later. So here's a simple demo of it. So it's a chat app. And so when it developed, it actually ran on a desktop application. So it's just like chat, like I'm just saying, okay, hello, Scala days, and get a response and so forth. And it runs faster. You send a message, it goes back to the IDE, and then you get back to it and so forth. So you fire it up, then there's a simulator. And once you're done developing with the environment, essentially, from your console and so forth, you're able to see that whole interaction from your messages, so that it's actually downloaded from the Glue Cloud server, right? So once we see that interaction, once it's ready, we can actually literally then deploy this on your device. So that device will basically have that same interaction that you actually saw on the server side as well. So you can see that from the native run that was actually done. So isn't that pretty cool, right? So using Scala to be able to develop and deploy cross-platform apps that you created on your desktop now running on your iPad, essentially. Right, so that's a pretty interesting one. So from that, you can actually start looking at what are some of the differences between React Native, which is widely adopted, widely supported. This is a large community and so forth. But now thinking about being able to run it on the JVM, right, so that you can get the better performance and the better startup capabilities, right? So we can borrow some of those capabilities on what has been done in things like React Native and so forth, and then start it on the JavaFX and JVM and so forth, right? So you can use SBT, Scala, and also the LLVM and JavaFX capabilities accordingly. In that glue-on architecture that we talked about. So what happens is here, you're able to then create a new community of mobile platform development as well, right? So when Spark started and things like that, it was all Scala and so forth as well, right? So similar to Eka and Play. So now you have this ability, and you can definitely start new projects accordingly there. So there's no reason not to use the JVM essentially, right? So it's time to spawn a new mobile ecosystem on JVM, and it's something that we encourage you to try, and we will be, and Scala would be a good spot to start on that. So cross compilation, next step. So this is part of what we're going to be thinking of doing next. So of course Android will be down the stream. We talked about iOS, support for GC on iOS also, and deploying the mobile faster from the Java bytecode, interpreter for development and so forth, right? So that's an important piece that we're looking at. So the conclusions are that, basically, looking at productivity, energy, and time spent and so forth, it's a simple, point to your class path and setting this up in terms of the JVM options, enabling JVM CI for GraalVM. So time to start looking at that and so forth, example line sample logins. As a summary, with the compilation, you get, that 30-35% in speeds and things like that. Native images of Scala programs are fast, startup, and low memory footprint. And also it's, faster than your hotspot JIT compiler, which is the traditional C1, C2 architecture. You can encourage you to go and try it today. And also there are demos available on, you just go to the root folder of GraalVM. There's these 10 things that you can do. Today it was more Scala specific, but you can also do things like extending your JVM, polyglot functions, Chrome debugger integrations, and things like that. So this whole wide variety of it. And a lot of articles written on Medium on things like what are isolates, what's memory management, sandboxing, and things like that on top of that as well. So there's a huge community of effort behind that. And yeah, that's a key component to actually leave you a thought. So I have like maybe 5 minutes or so. I got some time. Be open up for questions that you guys have. Since I actually did it just in time or ahead of time, right? So if you will, yeah, go ahead, please. Yeah.
Hi,
yes,
my name is Michael. I'm from JetBrains.
Sure.
And I have a question. Have you tried running SBT itself with the GraalVM? I mean, like, you can invoke plain Scala compiler and it's faster, but the thing is, actual real-world applications are built with SBT.
Right.
And it also imposes some performance penalty.
Yeah. So we have looked at that, and we talked about some of the trade-offs that we saw earlier. So we do see, there are some trade-offs that we get when you look at things like ahead of time and so forth, when you're running and generating it from SBT and SBT package and whatnot. So we're looking at that, and if there is a specific, I think we're also doing quite a bit with JetBrains and so forth. But we're happy to open our issue up on GitHub, and we'll be able to take a look at it if you want to try that and let us know. Yeah.
Yeah. All right. I can talk to you.
Sure. Yeah.
After the conference.
That'd be great.
As well.
Yeah. Yeah.
All right. Thank you.
Yeah. Cool. Right. Yeah. I think too. Go ahead, please. Yeah.
You've mentioned comparisons of startup time between Scala run on a typical hotspot thing and combined with native image.
Yeah.
Have you ever measured the startup time against Scala.js running on nodes? Because actually, people do use Scala.js on things like AWS Lambda because the startup time is faster.
Yeah. Interesting. Yeah, so we do see that conversions. There's actually a project going on where somebody is using GraalVM for Scala.js, and then they're using it to go into React basically for that kind of development. So we've seen quite a few of these. We've done benchmarks like that. We can show quite a few of those. In fact, the ones that we released out there is pretty comprehensive. But then we have done other detailed ones as well, so we can actually share that quite out in the open and so forth. We want to keep it neutral so that you actually be able to comment on it and things like that. And we've done it also on other areas like with deployments of Graal with even Golang on AWS Lambda and things like that as well. So we've done that. We've done it with things like Kotlin on AWS Lambda for serverless functions, startup time. But those who are, I'd have to look at those articles if there were actually benchmarks. It was more an integration pattern that was being done. But I can refer them to you, and then you can always run a JMH at the end and get some results and so forth from there as well. So, yeah. So we've been doing quite a bit of stuff on the serverless side of things. The integration with AWS Lambda, and also surprising. It's interesting you asked, and I didn't mention this, that we have an integration with our own serverless framework we call FN. So we have a serverless framework in that sense, and then we've got that, and it's something that GraalVM together with FN, which is an open source project. It has a flow component and things like that, and how we actually run it in different cloud architectures, and what's the startup sequence, and what performance benefits you get. So the good thing is, from a GraalVM perspective, we're not locking anybody down. So we support, although we're from Oracle, so we support our own serverless framework, but we support another serverless framework. Microservices, we support all the wide variety of microservices that you saw there, both the open source ones and so forth, and we ourselves are an open source project in that way as well. So yeah, so that's the key thing. Message is that the open community and being able to try a lot of these, and especially when you're looking at things like microservices, serverless, and the mobile stuff, right? The mobile, as you know, we've been kind of locked into different vendor sort of requirements, but here, if we can have something that's cross-platform, and that would be really awesome as well. So, yeah. So I don't know if I completely answered both your questions, but kind of maybe halfway. But I'll be open to discussions later. So, yeah. Go ahead. Yeah.
A lot of the point for some of the dynamic languages isn't the language itself, it's the library ecosystem. JavaScript and R in particular have very large library ecosystems that aren't written in the language.
Yeah.
Can you say something about how you can use the R native libraries and things like that from within Graal?
Yeah. So in terms of our support for these native, languages like Node.js, and of course we get questions like, there's going to be so many libraries out there, so how are we going to actually support it, and what we're going to do? So on a daily basis or weekly basis, the teams actually download a lot of these samples of libraries and actually do cross-compilation support, testing for any conflicts that might be happening and so forth. So we do that individually for Node.js, for Java Stack, obviously, and also Python and third-party and so forth. For R, you saw earlier that we have the ability of invoking R from within Scala. So that's not from a native image, that's more of a polyglot API. So that's something that we potentially look at some point. But we already have a fast R implementation today. So if you go today to our stack here, it will show you a fast R implementation from within Graal. And you can actually start looking at some of these, so glossaries and so forth. So there's an implementation of fast R in there, and you can actually look at that. I'll point that to you later. So anyways, it's there, and so you can actually see that, and we'll look at the native architectures coming pretty soon as well. So we also did fast R benchmark with PGO, with some of the guided optimization, I believe, and so we published some of that results also on FastR on a Medium article. Yeah. Yeah. Okay, please go ahead. Yeah.
Did client sample use Scala language?
Yes.
Could you show the?
Yeah, definitely. So basically so this is actually, what we did here was actually a build using a Scala, right? So this is actually your Hello World Scala app, basically, that we ran, right? So this is Scala native code that we created. There are other samples here. So for example, if you wanted to look at examples that people are actually, creating Scala R and things like that as well, you can actually go in there and look at examples of, yeah. Oh, iOS sample. Okay, got it. So the iOS sample is we would have to look at the this example right here. Yeah. So I can share with you the desktop chat app that we wrote. It's actually available in open source. So the link is there. So you can actually go in there and you can see how we did this cross-platform compilation and so forth. So we work with another company that does the UI side of things, the mobile connectivity. But we can share the code, in terms of some of these areas. Let me check though what we can and cannot share, and then I can get back to you on that thing. So this is a simple desktop chat app. It should be fine. I think it's not a big deal. So I should be able to share that. Yeah. You talk about this one, right? So you're referring to this desktop chat app that we wrote in Scala. Before that. This one, right? Yeah, that's the one. Yeah. So we'll be able to share that. Not a problem. Yeah. I'll check and I'll definitely be able to let you know. So cool. At least we've got a start for the mobile piece. So I'm glad somebody asked that question. And so we'll, that's a good movement there. And we'll be happy to support you. And also great questions before that. So thank you, everybody. Great questions. And I'll be available for some other questions that you might have. Thank you.